record on this computer. All right, welcome to Coffee Compiler Club, 1st of September, 2023 AD, Common Era. And Cliff is off in the desert for Running Man, so I'm hosting from the middle of nowhere, as you can see. Let's see. We were just talking about Simon's language. We're hoping Simon would show up one of these weeks to tell us where he's at. That's the core lang on, he writes about it on soc.me, soc.me. But since he's not here, Adrian, why don't you tell us about what you've been up to? Or not? Can you hear me, Adrian?
Adrian? Sorry, every time a train drives by, like my internet cuts out for a bit. I don't know what's going on, some kind of physics. What I've been up to, kind of like so there was one thing I tried to make my language, or keep most of my language in semantic pass, like all in one pass. So I wanted to have like simple resolution and all kinds of things like just name resolution and stuff like that all in one pass. But I also wanted to allow for like forward usages where you can use a type before it's declared, and I also wanted to allow for shadowing. And I noticed this is not a good idea, because I like to keep it to one pass. I kind of have to do some backpatching, and to do it in a sane way. And also the way my data structures are designed, it was just a pain. So,
and this is code gen, so
no code gens. It's just the front end, just like the first two things. Just parsing and semantic analysis. And I tried to keep most of it one pass, but it's a silly goal, I think, to keep everything in one pass, especially if I want to allow for like forward usages. So it's
define pass.
Yeah, right. Yeah, I guess I don't know if you go through the source code like once and then at the end you do some backpatching. I don't know if this is still considered one pass. Like if you modify your AST.
No, what I was suggesting. So have you ever looked at? I think that's often called work list. Using a work list in a compiler. So the idea is a work list. So since ASTs are naturally hierarchical, you can imagine that every pass is somehow a percolation down that tree to the roots, right? Not the roots, the leaves of the tree, whichever direction you draw your trees, up or down. So basically, in a pass, if you get called too early in the pass to answer the questions you have to answer, what you can do is put the current node in a work list and basically say, for this pass to finish, you have to come back to me. And then you basically return from that point. And the idea is that it's still a single pass, but it's not, because any node can request a follow-up. It allows you to run out of order. And that's particularly nice for when you have circular dependencies or forward dependencies and things like that. So it basically says, no, you go first. No, you go first. And it's an error if nobody goes first. So basically, you're watching to see if there's any progress in one of these iterations, because you have, after the first iteration, you have a work list to go back to. So if the work list doesn't shrink, well, it doesn't change at the end of a pass, it's an error.
I see. Yeah, I guess this is exactly what I was doing. So I was going through the source code, and every time I would see a type that was not before declared, I would put it in the queue. And then at the end of it, when I'm done going through the source, I just go through this queue and see if in the meantime like this like type that I stumbled upon was entered into my symbol table at some point later, and I made sure I checked that the scope also matches. Yeah. So I guess I see. So yeah, that would probably then still be one pass. But yeah, I abandoned that idea with the work list. I don't know, just the way I like deal with type interning just made it ugly. But yeah.
Yeah, type interning can be ugly because sometimes you're having to represent a type before you have all of its constituent pieces ironed out. Yeah. How about you, Teodor?
Yeah.
Any time for playing with languages this week?
No, no, I didn't play with languages for months now because it's kind of put the project on the back burner. So too much stuff going on. So I haven't been coding for the language for months now. I'm hoping we'll come back to, but too much stuff is going on right now. So
What's the name of the project?
still has no name.
Still has no name. That's a good name.
Mm-hmm.
Has a good ring.
Yeah, no name, no language. Yet. So I can't share some much of the progress. So it's pretty much like we spoke. Most of the ideas I had for the language are implemented in some other language, but they are in the host language. They are not supported as well. I know they work, but I need to build a language with them in order to feel how I would work with these abstractions I have in mind. So not much to say here.
What are the main abstractions you have in mind?
Some, let's say somewhere around modules. So okay, I don't want to share the idea once I have to show it, but once, let's say, all of the libraries you build are all of the kind of modules, if you will. You will have to be you will be able to change their state, their implementation. They are like they have a graph representation for, and you can all of the functionalities, you can swap some functionality with kind of new implementation, if you will. So it's kind of all of the let me find the words. All of the state of the program is like a graph representation, and you can change the graph is like a type. It's typed functions, if you will, and you can swap one function with the same signature, but you can provide a different implementation, if you will. That way, your program becomes configurable. The modules are really modules, and they are kind of they can abstract of a lot of things that way. So
I hate abstractions, but I don't disagree.
So the main purpose of this is composability and configurability. Once, let's say you have a library, the library, if be it or let's say, if you will, you have some abstractions there, but if you want to change something in the program, you have to compose the program together with the implementation classes in order to change their behavior. Here, you will swap one signature for different implementation. You can add different you can compose the same signatures together like a function, and you can replace them, you can remove some things, and that's the way you will, how to say, you will manipulate the module like a collection of functionalities. That's kind of the gist of it.
Rewiring function pointers.
Of course, yeah, that's fine, but it will be completely type safe. Let's say the closest thing as a functionality would be the Lisp. You can import code, yeah, but the list is untyped. Once you import code, you have to interpret it on the spot, if you will. But here, what you don't import, you just manipulate the signatures inside it. So that's the main point. The code will behave like a collection of elements.
That'll be interesting.
I've kind of gave it away.
Well, it'll be interesting to see what the abstractions are that the programmer gets to work with to actually rewire. Because I could imagine, in a complex application, there's a lot of, there's a lot of call sites.
Of course. That would be the main problem. The main obstacle here is how to manipulate that little signatures, because they pretty easily will become hundreds of thousands or even millions of pretty much, and how you exactly manipulate and replace one signature with different signature inside it.
Cool.
So yeah, that's the main idea. I have it in a library, and I've in a clunky way. I know it works. So you can from here. Let's say the main thing, it will be like composing functions. So once you compose a function, you are handed back the new signature, the composer signature, right? But in here, you'll have the different state of the function which you are composing. So you can change one signature with the same signature, because otherwise it wouldn't match. But if you provide the same signature, you will be able to swap the implementation. You will be able to swap the function you are composing, and that way the main points, the main abstractions here are when you are changing the signature. So like you're composing the and then, the function in Scala like and then and something else, and you are composing the other way. You are composing functions with the same signatures. Let's say if you are composing functions to A to B, they are stacked together. That's why it's called a stack. The collection is called a stack. If you have a functions from A to B, they are stacked together. If you have a function from B to C, they are chained together. So the whole signature becomes A to C. So the main point is it's like a collection. The A to B functions and the B to C functions are still there, and you will try to let's say if you can replace the function from B to C with another function from B to C. That is the main goal here. That is, to me, it's a pretty powerful abstraction to manipulate.
You call it a stack and not a chain?
Or... Yeah. The stack is when you're stacking the same functions together, and the chain when you're chaining the transformation function. That's called a chain.
So that means that function composition is a very primitive in your language, right?
Yeah, that is the main goal.
I see. Cool. That's cool. Yeah, because function composition is usually not like
it can demolish any kind of complex system, and just Cameron pressured me to give it away without an implementation. So that is the main idea. The other idea are how the configuration part. How are you configuring the system? Some things in the system, like the parameters, let's say you can mark it as the main point here, as you will be able to require some type inside this function composition. and it will be the main point. It will behave like the Scala implicit. I want this type like a parameter, and it will search in this composition to provide it. That's one way, and that's you can mark. Let's say you can mark it as a required. That means you will have to provide it, and maybe you can mark it like with the default implementation, which you can change later. So that here is the configuration part.
Are those functions all supposed to be pure? Like, is that kind of like where you're going with this?
I believe they don't have to be, but I believe they will be. There's nothing dictates that they won't be. If they have side effects, if you swap the A to B function with the new A to B, it will swap completely the functionality without all its side effects. It will swap the new implementation of the A to B function with all of them.
So interestingly, Alan this week was apparently researching aspect-oriented programming, which
that's kind of
this
like
is somewhat related to what you're talking about.
Yeah, that's kind of like it.
I have to agree with this because I don't think, like, I've been reading about aspect-oriented programming, and the more I read about it, the less I understand. I think, it's just saying, oh yeah, you have functions and you swap them out. I don't think that's an accurate description.
So I don't know if I made the gist of the idea clear, but that's why I want to try it in a new language, because you have to implement it. You have to support hundreds of thousands of signatures, lookup and replacement. So that would be the challenging part. Hundreds of, maybe even millions, because every function on its own is like a piece of the collection, like you can manipulate on its own. So you have a million functions that become cumbersome, become expensive to support this abstraction. That would be the main challenge here. So I don't know. Maybe I can try to share too. Yeah, is the share enabled?
Yep.
Okay. Can you see the docs?
I can see the CCC doc.
Okay. So let's try it here. If you have let's say, I will build it like in the more the Scala way and try to, let's say, I have a function X with some abstract parameters, and A to B, and A from A to B, let's say. To B. That be the Scala way to define it. I'm not interested in the implementation, so I can compose many of the A to B functions, right?
So is that A and B there, are those existential types? Is that the idea? Or
they're abstract types, they're unknown types.
So there is some type A and there's some type B, and this is a function that takes an A
from A to B, yeah, and you can compose many of these functions with the same signature, right? Let's make it more concrete. Let's not say abstract. Say from int to int. Okay, that's one way to it. So I can compose many of these int to int. I can then maybe and then. Yeah, the fact I'm trying to illustrate here is that you can have multiple implementations with this signature, correct? Yeah. So in the Scala way, you are in the Scala way, this whole signature would be int to int, correct? But in this abstraction, all of the signatures are here. All of the signatures would be in this collection. This is not a resulting type. It's actually the whole collection of computation. And let's say I name it. Let's name it. Name multiply or something. Well, so in the Scala way, that this would be int to int, but in this hypothetical programming language, you will have access to all of the int implementation. So you can say multiply replace x2 with some replacement x3, for example. Be it here the x3 has to have the same signature because it won't replace it. It will actually search for the symbols inside here. Right now they're classes, for example, but in a programming language that can implement the concept in the language, you will be able to access the function literals. So
are you doing your prototype in Scala?
Yeah, it is a Scala prototype.
Okay.
I have a question. So, like, do I understand correctly that these this composition of these functions together form some kind of, like, you call it like a stack that that is not just reduced to like a flattened int, but more like the structure is maintained.
Yeah,
the
structure
question
is collection. Yeah.
So, multiply this term. What type does it have? Like, what is this?
The resulting type would be int to int, but you are supplied like the collection, all of the collection you are imagining, like replace, drop, reverse, all of the operations are list support because it's a collection of functionalities. So the end result, you will have to it's not entirely known, but you have to materialize. Let's say you have to build. If you build it, then it becomes a function from int to int. So while you are not calling build, you can manipulate the collection. When you call build, the collection is frozen, and the resulting term here would be a result is a function from int to int.
Okay, I see. So basically, this collection is built at runtime. It's not
it's a compile time only construct. Some other things can survive actually the runtime, but they have to have a suitable representation of a runtime semantics. The goal here is to manipulate all of the elements at compile time, and then you materialize it. That way, when you import, let's say you import the multiply collection functionality, if you will, I don't know what to call it, you will be able to manipulate its contents right up until you call build. So the magic here is you can compose the collections themselves. Let's say add or something, multiply. That's why I was curious from the ML style model. The ML style the model can be parameterized as another model, a series of like a functor, if you will. And here is the same thing, but you can compose the functionalities themselves. I don't know if that made clear, but
so this replace function. So
go ahead. I'll ask a question later.
I was wondering. So basically, replace is supposed to run at compile time. So you have like kind of like a you have So you do have compile time function evaluation as a concept in your language. I see. Okay, cool. This is then I see. So you have like this thing you modify. I see. Okay, nice. Yeah, thanks for the explanation. That's pretty cool. Actually, like this does look a lot like stage compilation. And something I also would like to have in my language. Like this type of metaprogramming. It's cool. Cool.
So this functionality, you can implement much of the concepts in the most standard languages, but this collection, this abstraction doesn't need to have classes. We can emulate them here. So let's see how to do it. This example composes only one type of the function. Let's say here I have a different type, but with only one element, if you will. Let's say f1, which takes an int and returns a double. I'm using primitive styles because I have to think about classes and hierarchies, because I'm using a simple type here. On its own, this function is a collection on its own. So you can compose it with this, and then f1, let's say, and then the result here is a collection type from int to double. So, and right now you still have you likewise you still have the elements inside the collection, and you can manipulate them. So that is the way, that's how you are changing signatures here. In this example, they're stuck together. In this example, they're chained together. So they change the resulting signature. And the parameterization case here, if you will, I can't require, let's say I'm thinking on top of my mind here, require some signature, let's say string from side the so I mark it with some keyword, and that would mean I will have to find it in all of the collection I have. Be it if it behaves like an implicit, it will have to find it inside this collection of functionality at the end. When I call build, it will have to find it. So that way it will be available inside the body of the function, but I will not actually provide the implementation. It would be found at the when I call build, when it can. That is one way to maybe use it.
So Matt said in the chat, he said it reminds him a bit of computation graph and TensorFlow. Gave some links there if you want to copy them over.
Yeah, that's kind of it. So
what problem were you facing when this occurred to you? What was the inspiration?
The problem is one is to be able to change an implementation when it's already defined. So you can change, well, the parameterization and the change of functionality is actually here almost the same thing. I can reach out in the multiply and change something here. So if I have a stack of functionality, I can add a new functionality like this, and I can remove functionality I don't like. But the door is open for implementing abstract types. And in here, if you have something that has to be implemented, I can implement it later. Provide a concrete signature for that abstraction, if you will. I don't know, it made sense?
Well, I'm just looking at this and like, I don't know. So I actually have something similar in Strawskit, but like it's based on identifiers. It's not based on functions. So
yeah,
like
here the demonstration here is that it is identifiers. It will search for the identifier here. It will search for the name of the function, be it a function, be it a value, be it something.
So like I wrote in the second code block, you have this sort of evaluate with replacement function, and so it's that. So that it ends up being somewhere between a macro and a function, because like it takes the source code of the multiply function and then changes the bindings so that X binds to different functions.
And what would be the result of the signature here?
Strawskit's dynamic, so I don't have to worry about types.
That's the tricky here. Here is a statically typed. It will actually be the same collection, but with function x2 replaced with the function 3. It will still be the collection until you, let's say, materialize it, until you say, if you bind here from or something.
Like, what if you want, I mean, like, what if you have code that operates over integers, and then you replace each function that operates over an integer with the function that operates over floats? And so, like, then you want to run the resulting pipeline as a float-to-float function.
The replace function would require the same signature you're mixing in, because otherwise the structure would collapse.
Well, see, that's the thing. You know, if it's dynamic, it just works because it's like, oh, well, okay, now you're operating over floats and all the functions take floats, you know, and it's like, yes, it works.
Okay, the result here would be float to float. That's not a bad flow. It's not a bad answer, but you can't rely on the signatures here if you are changing them constantly. You have to know in your head that when you replace the function with the float function, that changes the whole signature. That's not my goal here. My goal is to replace a single piece of computation with another piece of the same type, and that would make the machine work. So if I'm replacing with another function with the same name, with the same functionality, with the same signature, the compiler wouldn't comply because you're swapping this functionality.
Yeah. So I don't know. I mean, there's certainly. I'm gonna write this example, so it's actually a valid example.
Yeah, that would be chaining the function. That would be chaining the function.
So like you're changing.
It wouldn't be replaced. It wouldn't be replaced. It would be if I maintain auto multiply here, it would be push, for example, push or add or something or compose or and then that's the operator for the function, and then function x3.
And you're adding x3, so maybe I'll change it x2 prime.
Okay, so replace, and the compiler would complain here because you're not changing. You are changing a function which signature doesn't comply.
Yeah, but like it's like a valid replacement. Like you're just changing the type of the function.
Why you're collapsing your structure? You have to build your abstraction. Here the example is easy because they are almost primitives. But if it's a more complex type, if the multiply replace here contains multiple collections of this functionality, and you change something on the bottom, and now all of the signatures wouldn't match. They have to be recomputed to the new thing, to the resulting collection, and that's not what you want.
Well, right. I mean, it works because you know the structure of multiplying. Like, I guess that's the real question is like, you know, how many assumptions can you make about the thing of what you're replacing? Like,
The replace it's here the valid things you have to have such a symbol, and the type of the symbol you are replacing it with have to be the same type of the x2.
Yeah, and keep in mind, Alan, like this multiply function could be used by 1,000 different call sites.
Of course.
And, you know, at least some of them will be expecting the return value to be of a certain type.
Well, yeah, but you're constructing a new function when you're doing the replacement.
But he's not constructing a new function.
That's correct.
He's rewiring something that exists.
Yeah, it's
like builder function. I mean, it's like this abstract structure, and then you call result on it. It's not. It's not modifying the original multiply function.
Yes, it would be.
He is treating his call graph as a mutable data structure up until he calls that build.
No, it's not necessarily build. Here the multiply is still the same. I wouldn't replace it here. I replace it in here. I replace it when I replace it. This is it's a new call graph. You still have the same multiply. It's not changed functionality. It's let's say at the last minutes it changes the things you want to change.
So Matt said, so perhaps it can be thought of as a principled special case of reflection, or even more special case of metaprogramming specifically for computation graphs.
Yeah, that's a way to put it, because you're manipulating the whole problem like macros would do, and the reflection part, I don't think it's just like reflection, because the reflection happens at runtime, but here is compile time manipulation of the symbols and signatures. So all of this functionality wouldn't survive at runtime. They maybe, let's say, if you will, you can find a way to make this structure survive at runtime, but it has to have appropriate semantics. Let's say here this function is still maintained inside this computation, this collection of functionality, but it's like DLL would need to be dynamically linked, which provide this functionality. This structure has to have semantics at runtime.
Matt mentioned that that would be basically like compile time reflection is still a thing, right? So reflection just means you're reifying kind of like your types. And yeah, if you do it at compile time, then
it's still with compile time reflection. That's about it. Yeah.
All right. So anyone have some good topics for today? I see Aaron hopping in and out. We lost you again.
I just would like to point out that I think this is really cool, and I feel like that we'll see more languages go for a like compile time reflection in general. And I think this is a powerful like metaprogramming tool, especially because you do have it's basically like a little dynamic language inside of your statically typed language. And the thing is, you do have like lots of information that, for instance, macros don't have. So yeah, that's I like that.
So once I gave it away, maybe next or even more next time I prepare an example what is abstraction could do. So I managed to keep it for years, but here Cameron just made me do it.
I need to do it.
Yeah. That's all. Okay.
No, but good example would be helpful, because you pick some problem that a lot of people either have recognized in their own past or could recognize as a possibility. So how it addresses it.
Yeah. How exactly would you like to? How exactly would you use this abstraction to build a better code, a more modular code, and code that you can configure after the fact? So you're handing this collection and you configure it at the last minute. You can the changing signature is the more powerful feature. The more stripped down version of the feature, you're configuring this collection with the things you are like to be configured with, and then you materialize it. So these concepts are kind of interleaving, changing the functionality by swapping the signatures and configuring like at the last minute, because you have to have something that you materialize at the last minute in order to be as flexible as possible. I would try to maybe the next or the next after that to come up with examples.
Cool. Very cool.
Okay.
Other topics today.
I actually have a short beef. Never mind. Yeah, no, I do have like one kind of thing that slightly annoys me. and that is that I've been reading a lot about like lots of people kind of have this belief apparently on the forums that memory safety is such table stakes that like if you're not implementing memory safety in your language, you're doing the humanity a disservice and you're being immoral. I mean, it's kind of a meme, but actually I think there are like true believers of this. And yeah, whatever. This is like something that slightly rubs me the wrong way. But then also there's something like people keep mentioning the 70% like CVEs are memory safety vulnerabilities, and then they use it to praise Rust. And the thing is, like if you actually look at the details of these statistics, 35% of those, like 50% of those 70% memory vulnerabilities are actually out of bounds reads and writes, which can be avoided with bounce checking. So like, you don't need a super complicated lifetime system and border checking to prevent out of bounds reads and writes. Like it prevents other things. The use after free dangling pointers, like data races. Okay, yeah, sure, but like that's a much lower percentage of things. And once you're writing high performance code, then you're anyways like using arena allocators and unifying lifetimes left and right, using indices in Rust anyways. So I feel like I don't know, just I see lots of like Rust focus in the language discourse, and I think it's like people have a too extreme view on this thing, and they kind of slightly overvalue these verbose lifetimes. Like I think they don't pay for themselves in many cases, and like quoting the 70% like memory CVEs, I think it's a bit disingenuous. So yeah, that's my slight beef. Right. I don't know what your guys' opinions is. But the thing is, like, also this hits a bit home, like close to home, because I'm writing a memory unsafe language. At least I have not made good plans for memory safety. So yeah, yeah, so I take it slightly personal, but yeah.
So okay, so I mean, of course, I'm a big memory safety fan, but I found that people disagree with me over my definition of it. So I think that if you don't free something quickly enough, that's a memory safety error. It's called a memory leak. And so therefore, if you leak memory, your program is memory unsafe. And like nobody seems to agree with me on this. They're like, oh no, use after free dangling pointer, blah, blah, blah. Those are memory safety errors. But a memory leak? No, that's like not actually a memory safety error.
So actually, you're not talking about a leak. You're talking about simply holding on to something that you no longer need.
Well, yeah, I mean, you're saying that's not a memory leak.
No, I'm saying terminology matters. So you called it a memory leak, but what you really meant was memory retention.
I mean, let's say you have a big like hash table or something, right? Okay.
I've had big hash tables.
And you have like lots of like objects stored in these hash tables under different keys, okay? And then like you have a pruning procedure that removes things occasionally. And like it has a bug. Like sometimes it doesn't prune a key even when you're never going to use it again. And so then like it just sits in the hash table forever, and the hash table, it grows and grows with things like this. And then eventually your program runs out of memory, right? That's a memory leak.
Well, I think, well, it's what you said earlier a minute ago was spot on. You said, and your pruning thing has a bug. Okay, I agree, it's a bug.
Right, and I'd call that bug a memory leak.
But memory leak has a different meaning. So you can't just take someone else's term and assign it to your current design.
Well, what's the different meaning? That's where I'm getting confused.
I thought memory leak means just like you have some kind of objects that you can't like naturally reference again via some like except creating the pointer out of thin air. You just can't get back to this
Right.
piece or like this object.
So memory leak in C basically means that you had a pointer that you mallocked or whatever, and before you called free on it, you lost that pointer. Well, or no one calls free on it, right? So it's malloc without free. But specifically, it's for something that you no longer have a pointer to. So that's a leak because you've leaked a valid point.
Well, and this is the same thing. You have a hash table, but you're never going to look up the key in that hash table.
Right, but predicting the future is different than than dropping a pointer without being. And that's the reason I'm saying the term memory
Oh, the pointer is just an integer. You're already predicting the future when you're saying that, you've lost the pointer, because like maybe, it does some weird pointer arithmetic and it comes up with the pointer later.
Yeah, I mean that's like called I think provenance or something. So basically, like if you have a pointer and it points to an allocation, and I mean, yeah, if you do transformations on it, it's actually a very tricky topic, but like yeah, there needs to be some kind of logical way for you to get this pointer back. When you say like you could say, for instance, you have a pointer to an object and then you offset it by some amount and you store it somewhere. And then when you retrieve the pointer again, you offset it back and then you have the allocation. Well, the thing is you can still have this logical chain of modifications of this pointer. So the pointer is known to have like this provenance. So you like basically it was not lost anywhere. But of course, once you're putting like, I don't know, once you were transforming it into a number and doing some weird stuff on it, I guess then it does become a bit of a gray area, probably. I don't know.
I missed most of the conversation and I just got back from lunch, but I think that pointer stuff you just mentioned is only really important during optimization. Like outside of that, I don't know if it affects things too much.
And provenance is important for like proving formal like semantics of your like memory, just memory handling, like yeah, especially like aliasing or something. You need to have some kind of like formal framework to define like what is an allocation, what does it mean for a pointer to belong to something or point to something, like yeah, I think so. It's not only for optimizations. Like I learned about it from the from the people working on the Rust compiler and making these like memory analysis tools. So their provenance was really important.
Do they do memory analysis? Because I never heard of that.
Like, there's this tool called Miri, which is an interpreter. So like it's just a kind of like a
that's
virtual machine.
I think that's LLVM, but I'm not 100% sure.
I don't think
Like,
so.
I don't know which team works on that, or maybe I'm just because there's another one that's I'm probably thinking of the other LLVM project, the middle. They have some kind of like middle end for GPUs.
MLIR stuff?
It's not this one. It's called.
Yeah, that's the one I'm confusing it with.
Yeah. I'm not talking about MLIR. I'm talking about Miri. That's called what's called MIR only.
Okay, yeah, that's what I confused about. All right.
Yeah, an interpreter for Rust mid-level intermediate representation. That's the name of the project running.
Does the Rust project even do anything with it? Because as far as I know, their board checker hasn't changed for a long time.
Oh wait,
sorry.
go ahead.
No, they are definitely using it for many things. Like first, this interpreter is used for the like the compile time function evaluation, as I understand. So like Rust const functions are interpreted with this interpreter, and like many people are using it to prove soundness of their programs, because like it can check many things. It can also check like data races and things using some kind of there's also, I don't know, like some cool stuff, like trying to emulate a weak memory model and using some kind of timestamps. I need to look at this again, but yeah, basically, if you want to prove soundness of your programs or of your unsafe libraries or something, a good way of getting there is to run everything through Miri. So most libraries that are like really rock solid use that. Yeah.
Yeah, so what I wanted to say was where I've seen it is people using unsafe Rust, because unsafe Rust is, well, I don't know. I mean, it's not that it's unsafe, it's that it's hard to use because it has so many confusing rules. So basically they run Miri over it and it checks some of those rules. And so they make fewer mistakes when they're doing things like handling raw pointers and so on.
So is today pick on Rust Day? Because Levo's not even said anything bad about it yet, and you guys keep piling on.
You guys know how I
don't
feel
say-
about that language.
I said
No need
something
for
bad about it.
comments.
Yeah, I think Rust is great, you know, for the people who like writing terrible programs. I mean, it's not like
I mean, also
It's
I
so
think
rare
Alan,
to it's so rare to agree with Alan, but sometimes you got to do it.
I actually think like Alan brought up a good point though. Like, first of all, I mean, memory leaks being an error that you need to like, respect. Is I think is a valid point. I mean, that is I would be able to classify it as like maybe memory safety issue, but there are also other things that I think sometimes fly under the radar, or people like have a very strict notion of correctness sometimes. Like for me, I think yeah, this is another beef. I don't want to be too hot-headed, but I think performance is. Wait a second, guys, can you hear me?
yes.
Okay,
Yeah.
sorry. Yeah. So basically, like, when people focus on correctness, they usually a lot of times focus on like inputs and outputs of a function, and like, this is a lot of times what these specifications do, and in these dependently typed languages and stuff. But I think like, things like memory usage or efficiency, or even performance, can just as much be a correctness issue, and not only if you're dealing with like hard real-time stuff. Just generally, like if you have a compiler and it takes 1 year to compile a program, you've failed making a compiler. Like it's garbage and no one will use it. So the like performance, for instance, is definitely a correctness issue, I think. But
the main
no one, yeah.
The main hurdles of this would be a concept you can represent the memory layout, if you will, to at compile time prove something about this memory. That was the advance of the Rust. It found the concept. It's not Rust particularly. To the people from the 90s are saying that linear ties can eliminate garbage collection, but the Rust is the first language to actually implement that concept and put it to work. So that was a concept to figure out how to represent a memory, like a sequence of steps, if you will. So like to borrow some of the linear type concepts, even be in a weaker form like affine types, but they made it work. That is the main advances here.
It doesn't work very well, like as a whole.
They still have to expand the concept to include all of the power of the linear types, not just the affine types, the linear types, and there is still something missing, because if you cannot implement the famous linked list, so the memory has to have some kind of orientation added to you to know that it's going to from one memory to different memory. So there are a few concepts that are missing there, but they are getting there, and with a few enhances, that would be it.
Linked list is one of the things I'm planning to tackle when I implement memory safety, and I started implementing memory safety, but for the most part, I've just been cleaning up my type system.
So as you see, it needs more than affine types, because you have to have a notion of orientation of that memory. So the Rust right now cannot figure out because be it the same type, it's a different memory location, if you will.
Yeah, I plan to do something. I plan to implement that with allocators, but I mean memory pools. But allocators is probably a better word, because maybe I don't want to demand you use a memory pool. But yeah, it's going to be a while before I actually do that or get to it.
Back to the structure I presented, it's actually pretty easier to define the allocator here and just pull it across this collection of functionality. And be it, if you will, if you even be it in, even swap it and change your allocator, it would be easy, if you will. So that's my thoughts on the linear types. They're quite powerful, but they're not rigid. They're full potential yet, because there are obviously a few bits missing.
Have you used a language with linear types? Like I tried ATS a bit, and I got scared off a lot by the compiler, but I don't know. How about you?
Not particularly if you don't count Rust, because it doesn't have actually the full power of linear types. But I've experimented with a language with a more abstract concept, the quantitative type theory, that it's tangent to linear types, but it's not exactly the same.
Do you mean Idris?
Yeah, Idris, and I don't know on top of my head. There are probably one or two that try to implement the quantitative type theory. So it's debatable if you actually need to annotate how much times you will use a function argument exactly, or you just need the linear type version and you're done. So that remains to be seen. So a quantitative type theory is for the folks out there is annotating the function parameters exactly how much time would you have to use it. You can annotate the parameter with 0, 1, 2, or many, if you will. The linear type version is exactly once. The affine types are at most once, if you will. But in the quantitative type theory, you will be able to annotate exactly how much times a function parameter or something has to be used. So that's a nice. There is an interesting niche here, because if you annotate your parameter function as 0, that would means that it's a compile time construct. It will remain compile time struct. That is an interesting side effect of this. So it means that we wouldn't have a runtime representation. That is a nice way to experiment.
Actually pretty elegant that you can kind of like subsume both linear types and like guaranteed compile time evaluation in like one framework.
In one concept. I haven't seen it, just an idea. So here cameras are inside of woods, and kind of they working positively to share my ideas about type systems.
I have never gotten the linear type concept myself, but
so the gist of
some people really like it.
The gist of it is it's a concept to compiler track exactly how much a thing is used inside a program. So there are a few flavors of these linear types, which form something called a substructure of type system. It's that affine types are at most ones. That means the function parameter, if you will, because it's easier to represent, it may be used, it may be not used, but it may be used exactly once. The linear type, it must be used exactly once. That is the difference. And from here, that concept, the compiler can track the lifetime of most of the things, and track the beginnings of something called the beginnings of Rust ownership, or if you will. That's how you track how using something in the program.
One note I would like to add, I found an insightful comment of one presentation that actually, as far as Rust is concerned, types are linear at the level of values, ordered at the level of types, affine at the level of probability. So remember that the value parameters and lifetime parameters live in different worlds in Rust. So that's why people are sometimes confused, because it's neither affine. Rust is neither purely affine or purely linear. It basically mixes those concepts.
Of course. These are ideas, but they're not how to say strictly. They're just represented like affine types, like linear types. They're not an embodiment of them. They're just a concept that they use because they're helpful.
I think it's interesting, like this expression, affine at the level of probability. I guess this refers to like lifetimes in references, or like, I guess I should check out this blog post, or
Yeah, I
link
guess it's kind of
the
acknowledging that you could work around it as well with, say, pointer manipulation or something. Right.
I find at the level of probability, so I interpret it as they can actually prove that it's used at most once. That's to me is they can really prove that at the value level that they are really embodiment of the linear concept and can track precisely because they're linear concept, but it's not implemented for all the concepts in Rust. I guess so.
Man, I use linear
You're
types,
muted.
or I implemented linear types, but yeah, I don't follow what other people mean with linear types or do it the way they describe. Just kind of like everything in my compiler, I do it
What's
my
a
own way.
linear type to you? What is a linear type to you?
Well, I was just going by what you said earlier about it tracks certain things about the type or how it's used. Yeah, so I track. I just call it metadata, and I track like if something is a positive number. This is so I don't have to check if when you do array bounds, it doesn't. You don't need an if statement to check if it's bigger than 0 if it knows this positive value, and then yeah, I just track a bunch of things.
That's an embodiment of tracking of usage. Yeah.
What's the difference between affine and linear?
The affine is at most once, the linear usage exactly once. If you don't use it in the body of the function, which is count the type as linear, it is an error. For a affine type, if you don't use it, it's not an error. Because if you use it more than once, it's an error. That's the difference.
And usage can count as a distractor in C++, for example. So if you just construct the type but never distract it, that would be an error in linear typing.
Yeah.
Because you are not allowed to just leave the value bending, so to speak. Affine would allow for this.
They mean the linear concept is here, as Matt said, it's duality. Once it's constructed, it has to be destructed. That's
so does that mean in languages with linear types that you have some special way that everyone uses to throw away all the stuff that they don't need?
Yeah, there's some kind to retain it, if you will. The Rust have something to forget, maybe. I'm not exactly familiar.
I think it's called drop.
Yeah, drop.
So an explicit destructor, basically. Explicit unwind.
I'm just thinking about linear order affine and what Matt linked. Sometimes I think like programmers have a lot of words for things that barely anyone has implemented. Yeah, I don't see the points.
They're concepts. They're not, like I said earlier, these are concepts that some language support them, embody them fully, or they're just supports in some form of way. So if you have a way to track when a term of a function, a parameter of a function is used, then you are tracking in a linear type way if it's an error if you don't use it. So you have to. You implement the concept. It's not like a recipe.
I don't think anyone implements it. I think they just like to talk about it.
Yeah, there's some exotic form of this. Yeah, why not?
Because I certainly never called it any of these.
Yeah.
I mean, this is related to linear logic. So in computer science, there is already linear logic which reasons about something which could be compared to using things exactly once. And that goes back decades ago. So I think that was already invented in mathematics and logic, and computer science just took those terms because they already existed and were out there.
Yeah, why not? The linear logic is elegant in the way to track something use exactly once, 0, many, or more. That is the lingo of the logic, that you can categorize how something is used because it's elegant and easier to represent.
Definitely not a widely used concept, though. And just thinking back over the languages that had it and didn't have it, the ones that have it, at least until recently, if you could say that Rust has something like it. Most of the languages were academic, like Idris or similar.
These concepts are harder to make practical. So Rust is actually one of the first that made such abstract concept practical. So it's cool to have. It's cool to have a dependent types. It's cool to have all these things, but can you actually do something efficient with it? So the linear logic is a concept that can actually get rid of garbage collection.
I was going to say it's basically the other side of the coin from garbage collection, right? Because the benefit of the linear type is, assuming someone's not doing something crazy with pointer arithmetic, you can provide certain guarantees over things, the lifetimes of, not that they necessarily are bounded, but that they never escape the front edge of the waterfall. If you think of the each linear transformation being a kind of a continuation of memory lifetimes.
Yeah.
So.
Yeah.
I don't know if anyone said this already, but Cameron, that looks very comfortable.
So you're muted, camera.
Sorry, I said other than mosquitoes, it's pretty awesome.
So it's all awesome. It made me share my ideas.
It's actually a virtual background leave while I'm in the office.
Oh, that would be a shame. So next topic. Someone have a question or something?
So Mahmoud, do you want to say hi? You've been quiet.
Hello.
Oh. Hello.
Hey.
So what have you been up to?
What I've been up to? I'm currently doing some research on GPU stuff.
I wanted to research that, but it's a little difficult.
In what area? In you are researching the GPUs?
Currently, a lot of hashing stuff. Not like crypto stuff, but hashing actual data. I can't really talk about it. It's government stuff, so
okay.
But
you can tell us. You just have to kill us afterwards.
Yeah, especially since it's getting recorded. So yeah.
So accelerating the calculating of a function hash of the function using a GPU, is that correct?
Yeah, that's part of it. Yeah. And yeah, I'm looking at it and trying to.
I don't suppose you're breaking passwords.
I'm not breaking passwords now. I can
the other day I was looking at like some kind of password recommendations, and all I could think was, why are people recommending things when they have no idea how to break passwords or how easy it is to break a password? I think I saw like some competition that could do hundreds of thousands on a GPU per second, so they can crack like many millions in a couple hours.
When you said password recommendation, it sounded like people are asking what they should use as a password. That would be funny.
Yeah, well, like the strength, like add a number to the end. Like when someone says you have to put a number, it's going at the end.
Yeah, depending on the hash, though. it really doesn't matter how many billion they do a second, because it still takes forever to crack a password. So, you know, obviously the algorithm matters a lot, and the key size matters a lot, but with modern stuff, you're talking about, you know, something like, I've seen some of the numbers, you know, in terms of computer hours, though, it's past the heat death of the universe. So.
It's still quite a lot. Yeah.
That's like encryption. I'm just talking about plain old boring passwords, like using a password-based key function, or I forget what it's called. Actually, I think most sites just use like SHA hashes.
Mm-hmm.
So here we have to the distinction to, is it cryptographic or we just made unique?
Well, because there's two general attacks. There's a forward attack and a backwards attack, right? So the forward attack is you try different combinations, but you know, any web server worth its salt is not going to respond immediately on, you know, on a repeated login attempt. I mean, even Linux, you know, slows down as you're trying to SU repeatedly, right? So it's the same concept. So on a forward attack, you foil the attacker by simply dead-holing them for an increasing period of time before you respond. The backwards attack is the one I was referring to, where you have the hash and you're trying to reverse the password from it. And in that case, anything SHA-256 or better, you know, is going to take an awful long time to reverse. Where a long time may be longer than the planet survives.
So
Even with,
here is depend in here it depends on the key used.
Well, there's two things. There's obviously key length, which, you know, it's kind of a generic term, but generally speaking, the hashing involves very, very large prime numbers. So you have a space of 2 to the 256 or 2 to the 512, and then you're picking, depending on which algorithm it is, you're picking either one prime number in that space or two prime numbers in that space, in the public-private example, where the public key is one of the prime numbers and the private key is the combination, the key pair.
Yeah.
But basically, you know, it has to do with the irreversibility of a modulo. You know, if I tell you that the number is 3, and that's the modulo from 7, what was the original number? Well, it could be 3, could be 10, could be 17, could be 24. And on
it's not so much with prime numbers.
Right. And with a 512-bit unsigned value, that it would take me quite a while to try to test all of the mod 7 equal 3 inputs. And that's the idea behind using the prime number, is that so for any space of numbers 0 to some n, any prime number smaller than n will never repeat itself until you've covered every value 0 to n. So the way you can think of this, say 10, for example, if my prime number is 7, I add 7 to 10. I'm sorry, I add 7 to 7, I get 14. So I mod 10, I add 4. Now I add 7. I'm probably messed up in there. But basically, it goes around and hits every number between 0 and n before repeating. And that's the reason why the primes are used for crypto. Fundamentally, because it makes it much harder to attack the mod, any of the mod functions used for the hashing. I don't know, Mahmoud, you can probably clarify what I was trying to say, since you actually work in the field.
I don't crack password either, but sure.
Well, I have a
yeah.
So I was looking at like what was it, the Web Application Security Standards, and so I was thinking like, you know, I don't know, maybe there's some way to design a programming language that supports security somehow, you know, like prevent SQL injection attacks, or
I think that's a library thing.
that's secret, don't leak this to the internet. I don't know. It's sort of vague right now, but I guess I wonder if anyone has thoughts on how to implement security in a programming language.
No, I think you would just have to have certain types in the standard library that says don't, you know, copy this, or zero it out before you free it. Like, I don't think that's implementation for the compiler. It's just the standard.
I think, yeah, like there are some languages that have these capabilities. So like, I don't know, some things that encode your like permission to do things. I don't know, like for instance, you could say by default, you don't allow third-party dependencies to dereference raw pointers. Like that would be the most egregious like permission that you can give them. But yeah, that does sound like maybe a standard library thing where you encode the permission to access maybe file system or network or things like that, and you can pass that on to the dependencies if they need it. And like if it's, for instance, a simple data structures, the data structure, all it needs is really access to an allocator probably, and it doesn't really, yeah, or something like that. But I actually don't know exactly how these capabilities work. That's just one version of this term that I understood.
Yeah, Cliff was talking about trying a capabilities model in AA. It sounded like, and kind of a is it called when it's recursively correct, where, you know, if you're using a library, someone else uses that library, they kind of inherit all of the so that way you could build a library that's kind of whitelisted, I think is the concept, and then but anything that's not keeps infecting recursively anything that uses it. And that way you could have like one trusted library provided by the language platform itself. And, you know, this is more for statically compiled code, I think, than anything. In our case, we use more like a capabilities model via injection in Ecstasy for ensuring that the code isn't able to do anything it's not supposed to do. But Alan, that has nothing to do with SQL injection or anything like that. So I'm curious if you had any concrete suggestions or concrete examples of how to do it.
Well, I mean, I've been looking, you know, I haven't found like, you know, there's like a guy with a PhD thesis on like information control and type systems or something like that. And like, I didn't really, I read the introduction. I haven't read the full thesis yet because it's, you know, theses are long. But like, I get the impression there's some kind of like type annotation you can put on like a thing, and then it says, this thing won't be used for this, like only certain other parts of the program can use this. And so it's sort of like capabilities, but it's more like it's more focused on preventing leakage of information. So like there's certain information that's not observable outside of certain regions of the program. Yeah, so I don't know.
I'm sure Matt has some more links on the topic.
Yeah, I was expecting some PDF maybe about like reachability types or like
separation
logic.
Okay, so there's another one. So like the way they do it in like the security things is they make a pretty picture of like the architecture of the program, and then they draw like arrows and stuff for like the information flows. And so like there are actually several tools that actually generate these diagrams. Like you can put annotations in the code, like this, generates information, this, accesses it, this, protects it. This is a security control that stops it from being accessed, that sort of stuff. And then like this third-party tool just sort of goes through the program and it generates this, data flow diagram. And so like I was thinking maybe there's a way to automate that. You're muted, Cameron.
Is that focused on like ahead of time compiled languages, like a C language, or?
Well, like I think the main one is Java. Like it's really designed for Java. Because
So
it
much,
just sort of,
much less ahead of time then.
yeah, it sort of fits in with the like the annotations. Like you can put annotations in Java doc and it's extensible that way. So this is just another annotation.
Interesting. So, other topics.
If I may, I was actually curious about, like, I want to circle back to Mahmoud. Do you have, can you speak about like what you use to compile to GPU? Like, do you use CUDA, like C++ or something?
Sure. I'm trying to focus actually on Java. So I'm using LWJGL, the lightweight Java gaming library, which has an OpenCL and a CUDA interface. And it's actually, yeah, it would be easier actually to do it in C++, but I'm trying to focus it on Java because it just works with the rest of the infrastructure actually, basically. And it's Java. I mean, say what you will, Java is awesome. So that's basically my thing.
Is there like if you had to think of maybe some language features or just designs of a language that make GPU programming nicer or like easier? Because so for instance, I was always curious, or just wait, first question, did you program FPGAs before or used some high-level synthesis tools?
Yeah, hello world kind of stuff, not really like very in depth.
Is it similar to GPU programming or is it just still different?
Similar. It's actually worse. At least it's my opinion. Everybody's opinion can be different, but I think the APIs for GPU programming are they have like a lot of boilerplate to set up to do the most basic thing. I want to say it's comparable to OpenGL, but it's much worse than OpenGL. It's comparable to Vulkan if you've ever programmed Vulkan. Like you have to like write like 2 pages to just set it up, and after setting it up, the API itself, it's kind of similar to the new vector API in Java, I think since Java 16 or something, which I think it's very intuitive for people that do that kind of stuff for a living, but for people that have never done it before, it's a little confusing, I think. So I wouldn't say the API or anything is actually better, but the performance you get is kind of worth it. But you cannot apply it to every problem. I'm just lucky to have a specific problem that can be solved with that.
So how speed up you saw implementing for FPGA or GPU compared to the regular code?
That's a good question. So I'm still in the early stages. At one point, I really want to test it with like a farm, like a GPU farm. I'm not sure what the correct term is for that, but I think you can imagine like a lot of GPUs that consume a lot of power, and a lot of dead trees.
Farm is fine. Yeah.
So, but currently I'm just testing it with my own GPU, something like 3080 NVIDIA thing, GTX. And compared to my CPU, which is also pretty good CPU, I think I saw something like a 20 or 30x improvements. But again, for this specific problem, right? Like it's a very niche specific problem, and But yeah, the moment you start to veer off from that, I mean, I saw some people doing like proof of concepts of like, oh, I want to replace list in Java, for example, with my own list that does GPU, and usually sucks in performance, right?
Yeah.
How careful do you have to be about if statements and branches?
Sorry?
How
He's
careful do
asking
you
if,
have?
yeah, I was going to say, he's asking about the impact of branches on GPUs.
Aha. That is a good one. I haven't actually calculated that.
So if you're not worried about it, that sounds like it's pretty easy to use, and you can get the 20x performance.
Well, yeah, but that's the thing. I'm not sure if I'm getting the 20x performance in spite of it or just because it's that awesome. So I could be getting like 50x performance if I did like proper branchless programming, for example, or something like that. But I really have no idea. I haven't looked into it. But now I will look into it. So thank you very much for that.
Wow, yeah.
Oh.
I kind of was interested in GPUs because I was wondering if I can, because right now my compiler it's bottlenecked by memory, so I was wondering if I can put a part of it on the GPU, and then because it has like such good memory bandwidth, I could just like do half the work there, and then get it back at a fraction of the time. So the overhead transferring would just like even out, and I can get a win. But I'm not sure how the memory works, but I do know it's supposed to be more bandwidth on the GPU.
Yeah, that's one thing. So that's because my problem, at least, I'm dealing with a lot of data, and the memory bandwidth of the GPU is amazing. But again, it depends on your problem. So for a compiler, I'm not really sure it's worth it.
Yeah, I have no idea of how big the overhead's going to be. I was kind of wondering, do you know how the memory works? Because I heard they don't have to be side by side, and there's like a scatter command or something, or I don't know what it is.
Yeah, GPUs have too many cores and too many like I'm not sure if you can do that with the APIs that are available, but even if you can, if it's worth it to access the specific memory for every core or whatever, like we sometimes do with the CPUs, I'm not sure that's really a great idea. So, but again, I'm not an expert, so it might be completely worth it. But
And Nevo may also be asking about the scatter gather that you use when you're, for example, you can move a chunk of data to a GPU, and one of the OS APIs uses it's been years since I've done this, so but basically you give it an array of addresses and lengths, and then it basically copies it as a block, and that was called a gather operation, I think. And then when you're transferring it back out, you can so whatever the memory is mapped to the GPU buffer, you can then basically point to locations in memory that it takes that information and scatters it across your data structures for your general purpose CPU. Is that what you meant, Levo?
yeah. That's
Yeah.
also what I mentioned at the beginning. The API is kind of similar to OpenGL. If you've used that kind of stuff, it's like throw a lot of data and then point to some memory location with a lot of data, and yeah, just copy. Yeah, you don't always have to copy it, but it's better if you copy it. And Matt is saying something because he always says some cool stuff.
So branches are generally not a problem. You shouldn't assume branching is a problem for modern GPU. Anything you bought in the last 2 decades, at least the last decade, should be fine. The only issue if you have a widely divergent branch, like every single kernel iteration in your work will be doing something else, that would be a problem. Also, compilers for the GPUs will often replace the branches with select statement, vectorized select statements. So it's not as if you will be actually producing an if statement in or conditional control flow in your GPU code. And generally, do not try to force yourself to write some fancy, complicated branchless code just to avoid branches, because that may actually reduce performance on modern GPUs and be worse.
So I have one question, like the way you described how you write these programs, it sounds like you're composing existing APIs like that have already abstracted certain like GPU implementations, and you compose them together into a program. And like a language with enough abstractions probably can, like any language with enough abstraction power can deal with it. But is there something, like in your, like if you could just imagine any language you would want, like is there some kind of language feature that would be very useful to have some kind of like that can natively very easily be translated to like a nice GPU program? Maybe
APL.
I don't know.
I was saying APL, the array programming language. Wouldn't that be about as close as you could imagine?
Generally, GPUs are particularly suitable for data parallel programming. So if you have some identical code that runs over lots and lots of data, say an entire matrix, maybe we are flipping pixels from one color to another, or are increasing brightness of a pixel or reducing brightness of a pixel or entire screen. That's a very data parallel programming problem. GPUs are great for that. FPGAs, in contrast, are great for pipeline parallelism. This is something when you have to do one thing, hand it off to another task that's going to do another thing, and then it's going to hand it off to another task that's going to be doing yet one thing. And you maybe want to do several pipelines in parallel overlapping this. It's kind of if you are trying to, for example, simulate a circuit which is corresponding to design of a pipeline CPU. That would be one of the ideal tasks. So very, very different FPGAs and GPUs. I don't think there is that much overlap between these two. They are for very different tasks.
I see.
Maybe I heard wrong, but I think I heard someone say that you can use a FPGA for to analyze a camera, like camera data.
Could work if it's something that is producible as a pipeline, and I did see image processing tasks exactly decomposed into pipelines, so it may make sense.
I also, like, by the way, you mentioned you want to be like you want to do some compilation on the GPU things. If you are already going this esoteric route, you can, like, I mean, technically you can also like do UTF-8 decoding and lexing, like maybe even basic parsing, like in FPGA at line rate. You could just like put a very basic tokenizer in your NIC, maybe. Like you just receive source code over the
wire.
Parsing
on FPGAs. It's often FIX, which is a financial data format, and you would like to very quickly parse it to detect changes in tickets, well, in symbols representing prices of certain stocks. Although that's one of the standard applications, yeah.
I'm not sure if this exists, but is there some kind of like memory stick that's has high bandwidth, even though it might be it might have a lot of latency, like for CPUs?
Well, HBM has high bandwidth, if that's what you mean.
Is there like
hardware?
is there like a name for it, and can I use it on consumer hardware?
Oh, consumer hardware, that's going to be harder.
Oh, okay, yeah.
Yeah,
So
I mean, what Matt's talking about is the where basically it has, 16 times the pinout or something. So with DDR, with the common stuff, you've got only a couple hundred lanes total, and that's often split across two channels. So you're talking about 128 or 192 bits total in terms of bus width. With HBM, because they can actually layer it on top of the CPU, so they can put a ball grid array attachment point on top of the CPU. And so instead of 192, they might have 2048 or something. Right? So literally 10x the number of lanes, if you will. So the memory tends to run at a slower rate but because it's so wide, it can bring back, I don't know, take the 2048 case, it can bring back, that's 8, I can't do math. So it can bring back a 4 cache lines in a single iteration.
So for Sapphire Rapids, for example, Sapphire Rapids is one of those latest Intel Xeon CPUs. And
coming out
if
soon.
I think it's out. If you have 56 cores, and each would have capacity of 16 gigabytes of RAM, about 64 gigabytes, you basically would have a bandwidth of 1 terabyte per second per socket. 1 terabyte per second per socket.
Wouldn't the Xeon need to use like regular RAM or like RAM with ECC and not lag?
Xeon Sapphire Rapids has a version that supports HBM. You can also buy a version using DDR5 DRAM, but there's a version of this CPU. I know it's already deployed in some places, but maybe as a consumer, you can also buy a workstation with that. I would look for Sapphire Rapids HBM. It may cost a bit much though.
So I'm probably going to rewrite my Lexer or my parser eventually, probably after memory safety, but like a lot of my data structures are right next to each other. So I was like thinking it would probably be really handy if certain data structures or certain memory pools could use the high latency but bigger bandwidth memory. And just like I never actually used NUMA yet, but I was thinking certain allocators could use that, and it would just make my program go fly.
But in a way, I wouldn't worry about this because, well, I wouldn't worry about buying specific memory because this is where the trend is going anyway. If you look at just ordinary commodity consumer DDR, this is exactly what has been happening, is that the bandwidth has been increasing and the latency has completely stalled for more than a decade now. At least I don't think there have been significant improvement in latency of consumer DRAM for over a decade now. And it may even get worse, while the bandwidth may still be increasing, the peak rate bandwidth, which is important to qualify.
With the Zen 4, for example, you're getting, I think, 75 plus gigabytes for the socket.
Wow.
In terms of,
yeah. This is tempting me to upgrade my hardware, but I'm gonna wait like another year or two.
Right, but keep in mind you can still starve that. Like you can still starve even with that much bandwidth. You can still starve the CPU because they're now up to, is it 256 hardware threads on a single socket now? Is that right, Matt? They're at 128 core now.
Yeah, there's no way I'm gonna be able to use that many threads because even at 8 cores, I mean 6 cores, I can't even use half of them. Like the only reason why I use all 6 cores instead of 3 is because the caching on the other cores are helping, but without the cache, it's not.
I don't know if someone, by the way, have seen this new processor that Intel has presented at Hot Chips this year.
Yeah.
Do you know? Guess how many threads it has per core?
Shit.
It has 66 hardware threads per core.
6 per core?
66 per core. And because
66.
It has per core, yes. And because it has 8 cores, that adds to 528 threads.
That doesn't even make any sense.
Those are all efficiency cores, though. So they're the Atom.
It's not x86. What's another interesting thing? It's not x86 instruction set architecture. It's a form of RISC. It's basically a domain-specific CPU for a DARPA project. They operate on very sparse data, and they want to basically switch between the threads very, very fast, kind of like you would in certain GPUs, because otherwise you would be just waiting for memory anyway. Just an interesting concept.
It was mentioned there was it's like a barrel processor design. So
yeah, that's very close to GPUs. I mean, GPU is basically a very, very high-way SMT machine. Instead of having like 2-way SMT or a 4-way SMT, you have like, I don't know, 512-way SMT. There's a lot of more threads.
Yeah, I
So,
still can't believe the numbers. Like, that's a lot of threads.
to put this into a more compiler-oriented aspect, so the question is, what is a parallelizable in a compiler?
Well, this is more optimizing than trying to make it more parallel. But yeah,
Well,
I don't try to make
you have to design for parallelization in something like a compiler because traditionally the architecture is kind of global mutable for compilers, and that's the nightmare scenario.
Okay, the traditional way is a simple table, which the Lexington parsing can be embarrassingly parallelized per file. Okay, but from there, what can be parallelized?
See, the thing about parallelizing is I do it per file and not per file, but not try to parallelize one file because a file is like what, like a couple of kilobytes, like it's less than 100 kilobytes.
Okay.
So I don't see a point because to process 100 kilobytes, that's like less than a millisecond probably. So actually, I should really measure that, but it's really fast, and I just think that if per file, it's extremely simple to parallelize per file. So I don't even think it's hard. I don't even know why compilers are not parallel. Like, I feel like I'm the first one to do it, but I really have no idea.
As we mentioned, the Lexington parsing can be embarrassingly parallel. So there is something here. If it's not done, there is something that prevents.
I have the whole thing.
By the way, Livo, MLIR is parallel. It's the difference between MLIR and LLVM. In that LLVM, when it was designed, parallelism was not as being bank of a bug. So it's actually single-threaded, and it's hard to make it multi-threaded because it has this shared context object, which is a shared mutable state, and every thread would be banking on this. But MLIR specifically designed itself so that it doesn't have this shared context object. And there are compilers making use of that in MLIR framework.
I always thought the LMIR depends on the low-level IR.
No, you can actually have a compiler that produces MLIR and compiles straight to semiconductor circuit. Like straight away, you go from MLIR to a bunch of layers that result in a hardware circuit, completely without any involvement of an LVM.
So you can implement your
circuit.
You can implement your compiler in a hardware circuit.
Okay, because if Clang can emit it, it would be very easy for me to look at some of the outputs, but since it can't, I don't know.
There is a Fortran compiler called Flank, and that Fortran compiler is actually MLIR based. It has its own MLIR dialects, and at the end, those dialects are converted to LLVM. So that's the closest, I think, relatively mainstream language that uses MLIR for its own intermediate representations.
Is this for GPUs or is this like regular?
Oh, it's ordinary Fortran compiler. It can compile for CPUs and GPUs. I think you can even access this on Godbolt Compiler Explorer by Matt Godbolt.
Yeah. I should look into it.
Yeah.
Yeah,
actually,
it's fantastic.
He's an awesome guy. He's really great.
I actually talked to him. Yeah, he's great.
About like parallelization, I guess you can think like for instance, like if I was thinking a lot about compile time function evaluation, it's like most of the time the thought I go to sleep with and wake up. But anyways, like the computational graph, like if you have lots of compile time functions, then they form like a graph, and you can like work from the leaves up to the root, and like at every stage you can parallelize all the ones that have the same like depth, all the nodes. And I mean, building the graph first is like not so parallel, but like once you have it, you can,
yeah.
And
I think we talked about this last week. I think Alan brought it up, but I don't remember what we said, but or how in depth we talked about it. But what do you guys think about like not having compile time and just using a build script to do your compile time work? I can't remember if I asked this last week or not.
to build, or let's repeat, to use a build to make your compile time work. So
yeah, let's say I have a couple let's say I have structures and I want to generate functions based off of the structs, like
yeah.
like JSON deserialization or serialization or
Mhm.
both.
Mhm.
Instead of trying to do it at compile time, because I think Zik does that, and people
Okay.
use C++ to do
So
some
this is
horrific
this is already
templates.
going the C++
Yeah,
using.
so I was thinking both those would just increase both methods like templates and comp time increases compile time when I
Okay.
just have your build script
One
do it
question,
instead.
Livo. How would you implement your type system in your build script? And notice the required answer is that you have to implement it, because if you don't, then you cannot type check those functions for those containers you want to generate it for. So how are you gonna do type checking in the build
Matt
script?
spoiled it away, and the answer here is types. So you can make.
No, that's a good question.
Hmm.
Because I was thinking I should just start with structs, and structs are really easy to parse. And even if you don't want to parse it, I could just hand you some data. It's really easy to process. But yeah, types. I mean, yeah, if I want to look at parameters and represent types,
I mean,
that's a little
even
bit
if a
difficult.
programmer makes a simple typing mistake, you may be able to diagnose this and provide some kind of type checking error. But if you do not implement type checking error in your build script, then you cannot even provide good error messages to the programmers making simple mistakes. So I don't think that you're actually saving people time when you do that.
So Matt, I think he's talking about something else. I think he's talking about writing something in his language that then runs at build time to write something in his language.
Yeah,
that's basically
so not a build script, but
that's
rather
basically
build stage.
The
More like staging. Yeah, that's far more interesting.
Compiler.
That's far more interesting. Yeah.
Which we were kind of talking about earlier with Teodor's project that he unveiled his top secret project.
This is akin to a meta programming. So in order to compile type reflection is to print your AST and use the result of the AST as an AST in your program. Oh, head up. What is his name?
Yeah. But then you're not saving I mean, you can't really criticize Zik for increasing compile times in that case, because then you're doing the same thing, right?
That is the main.
No. I'm thinking you have to output it as a file, and then you have a readable file that you can look over. And you only generate that file when certain types changes or certain input source files changes.
But that's basically incremental compilation, right? This is
staging.
If you implement staging via, or if you have incremental compilation support for your staged metaprogramming language, then that's basically the same thing as what you're describing. Except incremental compilation has ergonomic benefits, because if you change the source file, the language figures out itself what to recompile. So that's quite nice. Then you don't need to.
Yeah.
See,
so
I gotta think about my answer later, but go ahead.
I have to say though, Zik does not the comp time functions are interpreted, and you can definitely make an argument that interpreting all of these that incurs latency in a big project. It's not like they're JIT compiling or ahead of time compiling all of these.
Has it ever felt slow to compile something?
In Zik, do you mean?
Yeah.
Well, yeah, the Zik compiler is actually pretty slow, and it has so much latency. I don't know. Maybe this is just my system. Maybe it's because I'm on Mac, but I don't know.
What version are you using? Because I hear the newest one is a little bit better, or a lot better.
I always use master, but maybe I did something wrong.
I wonder how many comp time functions you have.
Yeah, not many, and my projects are very small. But I do think once you have millions of lines of code and lots of comp time in there, I think maybe interpreting everything can be a problem.
You know what? I wonder if you can change the backend, or what happens if you try on Linux, because I think they have x86 backend, and maybe that's the reason it was fast, but I'm not 100% sure.
Yeah, the x86 backend is much faster, I believe. But coming back to the meta stage programming, using your language to generate your language is prone to slowness in every way, because once the language enters that realm, the capabilities of the language skyrocket at the expense of the compile time. So it is
Yeah,
what it
that's
is.
why I was thinking the build script has to do it on like a specific file will do it, and not the entire program.
There are much flavors at what stage your meta programming is enters, if you will, back in the compiler. So it's basically generates the code and enters in the parser stage again, and it has to be type checked in order to be visible from the rest of the program. There are places that the meta programming can resume, if you will, and that distinguishes at which level you're generating the meta program, in my mind.
So Adrian, what do you generally need the comp time support for? Where does that highlight itself as a good capability?
You're talking about where does comp time, like Zig, highlight itself, or as a good?
He wants to know about your specific uses of comp time.
Like lots. Like one thing, I'm actually writing a blog about it. I'll upload it in a few days. Basically, like one thing is memory efficiency. But actually, I have a bunch of examples for like my particular use case of writing like firmware and stuff. But like in the case of Zig, like for instance, for writing compilers, I mentioned this, like if you have a collection of enums and you want to make sure that you're not wasting memory and fragmenting all of your arrays a lot.
Right.
Then Zig can help you build a very efficient data structure. You can just like go through your enum variants, right. check all the tags, and then create
so
like
you're
a very
efficient. You're kind of building a compiler in a sense in the comp time, right? You're saying for this type I'm going to use 3 bits, and for that type I use 7 bits, and so on.
Right. Yeah. And you have all the size information, alignment, padding, everything about the types, the internals at your disposal, so you can make much more informed decisions. And also you can like it's much more composable. For instance, you can like this efficient enum this efficient enum type or container. It can be just like defined once as a library, and you can use it generically to create containers for all kinds of enums, even third-party enums. Because the problem with Rust is, for instance, that you have to like put derives everywhere on the enums. Like you have to with an AST-based macro system, you have to actually place derives at the location where this structure is defined, meaning that you really have a problem like just making these crazy transformations on code that doesn't belong to you. So just making really efficient containers and metaprogramming on third-party code is actually difficult and not composable in Rust, but in Zig it can be done. Like, and so this is like one example.
Does Zig have bit fields?
Yeah, it does.
Excellent. Yeah.
But basically it has custom with integer types, and they're using that to like they're using custom with integer types and defined struct layout to emulate bit fields. So you basically
Doesn't C++23 add custom with bit integer types now?
I think they did recently, yeah. Like it existed.
I'm slacking. I'd never heard of that.
It's really cool. I mean, it existed in LLVM as I remember, to enable high-level synthesis. So basically allowing your program, like written in some kind of C or C++, whatever, to be like lowered to something that can run on FPGA. And that was the original motivation. But like for me, for instance, I think this is great for just being a bit more memory efficient. Right. Or defining your enum niches as well. Like if you have a tagged union, if you can specify all the bits, you can actually build your own enums.
You're you're very constrained hardware-wise, which is why this makes a lot of sense. So that's a cool answer.
There's also another thing, like, yeah, like the thing is, if you do have this staged like programming thing, you also have other benefits, like, because I want to write, I want to have a language that is useful for like really bare metal stuff that has no runtime, no dependency, and is directly like used for firmware or something like that. And being able to specify the alignment of functions, the location of functions, for instance, the size, like the maximum stack depth of a call graph is quite nice. Like a lot of these things have to be done in languages using annotations. Like languages that were not designed for this use case, for instance, like bounding the maximum stack usage of a call graph, or like alignment or whatever. Like for all of them, like they later tag it on and allow you to add annotations on top of functions. But if you have the staged compilation system, what you can do is you can construct a function, and then you just configure this function object in your metaprogramming language by adding all of this information like alignment and other things. And then at the end, you turn it into a real function, and the compiler can then like make sure that in the end, in the binary, everything like it looks the way it's supposed to look.
By the way, speaking of adapting languages to constrained environments, you might want to take a look at embedded Swift that recently came out, and they actually got Swift to work on as a 10 kilobyte firmware on an embedded microcontroller using pretty much full language features. They didn't have to do that much compromises. So I think that's 10 kilobytes is pretty good for the binary size for a modern language with generic programming and pretty full features.
That's pretty amazing. I mean, Swift is huge.
Well, not so huge in practice. Remember, it doesn't really have that much in terms of runtime. I mean, technically C and C++ also have runtime, because like calling to malloc in glibc, that's a form of runtime. But those runtimes are considered to be small, and you can drop them. So that's actually pretty cool.
Well, we are at the 2-hour mark. Any other topics we want to hit today? Some interesting stuff on comp time and on GPUs. So Mahmoud, if you want, you could put together a couple slides on some GPU stuff, and we could do that another week. Because there does seem to be a lot of interest in GPU stuff. Obviously, stay away from anything that's work specific, but if you have some general pointers on GPU stuff, that'd be cool.
Yeah, it's not such a specific, but how to use them, what can you leverage with them, and that's in general, not some detail specific. That's
any other topics before we wrap up? We've got 3 Levos on the phone.
Levos are piling up.
All right. Well,
maybe it's the build script. Maybe it's the build script duplicating.
Yeah.
So you want to see my antenna? I don't know if you can see it on there.
Yeah, please show.
So that's it up in the trees. If you can see all white.
Yeah.
Directional antenna. So So last night I was out with the mosquitoes, holding my phone up by the window and turning it, a couple degrees, trying to zoom in on the best angle. It's amazing that it works at all.
How far are you away from civilization?
I don't know, but probably
like an hour.
20 minutes from the closest town, I guess.
Okay, not bad.
Yeah. Not too bad.
Yeah.
Well, very good.
Yeah.
What's that, Teodor? What were you going to say?
So we would love to join you, but we are satisfied with the view for now.
Very cool.
Yeah.
Good to see everyone, and I'll get this recording to Cliff, and he'll get it posted. So have a good weekend.
Okay, guys. Interesting talk.
Hey, guys.
Bye.
Thanks. Good weekend.
Bye.
Bye.